All right, guys, welcome back. Let's continue. Okay, after I finish this part, maybe we'll have very short break and we continue with 3.5. So we were talking about permutation matrix. And I hope you understood this. It's not so difficult thing. Usually, actually, this permutation method, we just need this if we need to perform the swapping operation. Swapping means interchanging some rows, right? Okay, so example, consider the matrix A, where is elements 1 to -1 and 3, 6, 2, -1, 1, 4. Okay, so now if you just try to find the LU factorization of this matrix, what do we get here? So let me just continue here, multiply the first row by a 3, right? 1 to -1 and 3, and add it to the second row. So here we have 0, and here we have 0, but -3, it is 5, right? So here we have -1 and 1 and 4. As see here now in the second row, we have zeros. I cannot create zeros under this. So what do I need here? If I just interchange this, so let me just actually label this by E again, okay? So E times A, it gives us this matrix that is 1 and 2, -1, -1, 1, 4, and 3, and 6, and 2, right? So now the first thing is, just right here, where is it? R2 plus R1, adding the first row to the second row, 1, 2, -1, and add this, it is 0. So it is 3, it is 3, right? So here we have 3 and 6 and 2. Actually, I can just perform the same thing. What is it? Here we have R3 minus 3 times R1, right? Also, at the same time, if you multiply the first row by -3 and add it to the third row, sorry, here we have, what is it? 3 and 6 and 2, right? So what is it? -3 plus 3, it is 0. -6 plus 6, it is 0. And 3 plus 2, that's equal to 5. Okay. So now, so from here, I can just write this E times A, that's equal to LU. What is our L? Unit lower triangle matrix is 1, 0, 0, 1, 0, 1. Here we have 2, 1, right? What is 2 and 1? That is -1. And how about 3 and 1? That is 3, right? But here we didn't do any operation. That's why it's equal to 0. And how about U? U is 1 and 2, -1, 0 and 3 and 3, 0, 0, 5. Okay, so once again, actually, what is this? The inverse of this E is just equal to itself, right? E inverse is equal to E. Why? Because you just interchange two rows. That's why now I can write A as E times LU. That is how we handle the situation if we need to do swapping operation. So now theorem. So if P is a permutation matrix, then the inverse of P is just equal to the transpose of T. Okay. So permutation means, what is it here? Permutation matrix, right? It's just the product of a few elementary matrices of this type, right? Just we obtain this by interchanging or swapping a few rows of this, what is it, matrices. So what is it here? Here, what we claiming here, that's the inverse of P is equal to PT, means that I have to show that here the P transpose, the P, or that's equal to P times P transpose, right? That's equal to I. So if it is so, then we just say that what is the inverse of P? It will be P transpose, because if you multiply P by this matrix, it's I. That means that this P transpose is the inverse of P. Okay. So actually here, all right, this P transpose P, right? The ith row of P transpose, right? The ith row of P transpose is the same as ith column of P, right? Because it's transpose. Right here, we can just write here P transpose. Okay, how to write this one? Maybe I can just write here row I of P transpose is the same as column I of P, right? So that means that then what is P transpose P's ij entry? This is how we multiply it, right? That means that we need to multiply ith row of P, that is row I of P transpose, right? And what is it? Column I of P, right? And from here, what is it? We know that actually this row I, P transpose, it contains only ones, right? So simply, it is just a standard unit vector. So here we have E transpose and column I and row I. This one appears in the same place. So that's why column I of P and also just equal to I. So that is equal to, what is E transpose E? If you remember, that's just equal to E and dot E, the dot product of these two vectors, right? So the dot product of these two vectors is equal to 1, right? It's like, for example, let's say we are talking about maybe 0, 1, 1, right? And the second one is maybe this 0, 1, 0. Okay, actually here one appears in the second entry. Sorry, this one is 0, right? Also the second entry, right? If you just transpose this, the order of one, it does not change. Okay, so that's why here we have, what is it? How about if we have, what is it? If actually they are in different places, right? Ij, right? Like for example, P transpose P. Okay, here we have Ij. So again, that is row I of P transpose, and here we have column I of P, right? So actually, if J is not equal to I, right? So here we have, let me just write here as a single one. So if I is equal to J, okay, see here when I, okay. If I is equal to J, it's the first case. So I need to write like this. So that's equal to 1. If I, J, right? I is equal to J. The order of 1 is in the same place. And how about if I is not equal to J? That means that these ones, they appear in different places. At the time, if you multiply them, that's equal to 0, right? What is it? It's just a definition of the identity matrix, right? Let's see here, IJ means that actually these are in the main diagonal, right? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Everywhere else, it is 0. So that means that actually that thing is equal to I. So which means that the inverse of this permutation matrix is just the transpose of that matrix. Okay, so now let's just the definition, I mean, formalize what we have learned here. Let A be a square matrix A, or actually it's already A, be a square matrix. A factorization of A as A equals P transpose LU, where P is a permutation matrix L, is unit lower triangular and U is upper triangular, is called the PTLU factorization of A. Okay, the first one is LU, but why do we need to define this? Because to reduce the given matrix into echelon form, right, we need to do swapping operation. That's why with swapping operation, we are doing this with this matrix, this P transpose. Example, find the PTLU factorization of A. Okay, how do we do this? First, I don't know if I can just keep this 0 at the bottom, right? The first operation is I need to interchange the first row with the third row, right? And maybe the second one is, I don't know, we should change now after that R1 with R2. Okay. So at the time, what we have here, at the time, this new matrix, right? Actually, I just did two things, that is E2 and E1, right? So that is, what is it? Actually, this 2 goes up, 2, 3, 5. And here we have 4 and 8 and 9. And here we have 0 and 0 and 8, right? If I just perform these two operations on matrix A, we obtain this. I interchange the first row with the third row. And after that, now the third is 0, 0, right? The first row with the second row. Okay. So what are these operations? It means the first one is, what is it? 1 with the third one. So that is 0, 0, 1, 0, 1, 0, 1, 0, 0, right? That is, let's say this E1. The second one is the first one, the second one. So that is 0, 1, 0, 1, 0, 0, 0, 0, 1. That's our second elementary operation. So now, after that, what is it? Let me just draw a line. The second part. So here we have 2 and 3 and 5. I should multiply, right? What is it? This first row by 2 and add it to the second row. Minus 2, minus 4 plus 4, it is 0. Minus 6 plus 8, that is 2. Minus 10 plus 9, that's equal to minus 4. Now here we have 0, 0, 8. I don't have to perform any other operation, right? So at the time, if I just label this e to e1 by p, what is p? P is equal to e to e1, right? So what is e2? E2 actually, e1 is 0, 0, 1, 0, 1, 2, right? What is the function of e2? Is just changing the first one with the second one, right? So this one will be, if we just change e1's first and second rows, so interchange them, what we have here? Here we have 0, 1, 0, and the 0, 0, 1, and here we have 1, 0, 0. That is our P, right? And what is P transpose then? The P transpose will be, if we have 0, 0, 1, right? And 1, 0, 0, and 0, 1, 0. It's just the transpose of T, right? So then PTLU factorization of A. This A, that is PTLU, will be, what is P? That is 0, 0, 1, 1, 0, 0, 0, 1, 0. And L is 1, 0, 0, 1, 0, and 2, 1, right? That's equal to 2. So it is 2, it is 0, 0, 1. And how about U? U is 2 and 3 and 5, 0, 2, negative 1, 0, 0, 8. So that is PTLD factorization of this matrix. Okay. All right, we have 2 slides left. After that, we'll have a short break. Find PTLU factorization of the following matrices. Okay, the first one is a lot of ones here. All right. So what can I do here? So the first one is A, right? What is our E1? Just I need to interchange the first over the second one, right? That is just a part 1. So if I just interchange R1 with R2, right? At the time here, let me just label this by E. Okay, EA becomes what? We have negative 1 and 1, 1, 2. The second one is 0, negative 1, 1, 3. It is 0, 0, 1, 0, negative 1, 1, 1, 1. All right. So I just need one of maybe 2, right, to reduce this to reduce rational form. So if I add this, it is 0, 0. So I need one more. Okay. Because also I need to, what is it? Interchange the third and the fourth row. So also I need this operation, R3 with R4. Okay. So if I do so, let me just rewrite this. So that is E2, E1A. So here we have minus 1, 1, 1, 2, 0, minus 1, 1, 3. And here we have 0, 0, 1, 1. And the third row will be 0, 1, minus 1, 1. Okay. So now, just if I add the second row to the third row, that's it, right? Here, what we need here is, I just need to add the second row to the third row. So at the time here we have negative 1, 1, 1, 2, 0, minus 1, 1, 3, and 0, 0, 1, 1. And here we have 0, negative 1 plus 1, that is 0, 1 plus negative 1, it is 0, 3 plus 1, it is 4. So it's already actually, what is it, upper triangular matrix. So now if I just label this by P, okay, then here we have P times A becomes L. What is L? 1, 0, 0, 0, and 1, 0, 0, and 1, 0, and here we have 1. And only this 3, 2, right? We did only one operation. 3, 2 is negative 1. And this one is 0, and the 0 and 0. 3, 2, this one is negative 1. All other operations we did anything, that's what they are 0. Right? And times U. What is U? Minus 1, 1, 1, 2, 0, minus 1, 1, 3, 0, 0, 1, 1, 0, 0, 0, 4. Right? Now, if I just take this to the right-hand side, we will have that thing. So what is A then? A is equal to P transpose, and here we have L times U. Where, what is P transpose? P transpose is, let me just write here, what is P? We just change, here, let me just write here, P is equal to, we interchange the first over the second row, so there's 0, 1, 0, 0, and 1, 0, 0, 0. And the third row with the fourth row, right? And that is fourth row, the 0, 0, 0, 1, 0, 0, 1, 0. That's our P. So at the time the T transpose will be, P inverse will be just transpose of this. That is 0, 1, 0, 0. The second one is 1, 0, 0, 0. Third one is 0, 0, 0, 0, 0, 1. And the last one is, let me just write it nicely. So here we have 0, 0, 0, 1, 0, 0, 1, 0. Okay. And that's how we find the what is the PTLU factorization of the matrices. And B, I think I'll just leave it as an exercise. So the last theorem is, what is it? Every square matrix has a PTLU factorization. Okay, that is, what is it? If you're given square matrix, right? It has PTLU. For LU, we are not sure, but for square matrix, every matrix has PTLU factorization. Guys, now I'll give a break, okay, 5 minutes. After this, we'll start the subspaces. Okay, we have still 20 more minutes. Then I will finish today's class, okay? Just like 4 minutes break, and you can just rejoin the class after 4 minutes.